Hello, this is lesson 2.1, day 2, dealing with outliers and extra practice on creating data sets. Today we're going to start the lesson by looking at how to create a box plot. Should be a review for you because we learned how to do box plots in Algebra 1 as a freshman, and I believe you even worked with them a little bit when you were in middle school. Box and whisker plot is created by using the 5-number summary known as the min, the first quartile, the median, the third quartile, and the maximum. And so to begin, we must find those values. We're going to start with the easy one, which is our maximum and our minimum. So 1 is our min and 81 is our max. Those are the easy ones to find. The median, if you remember correctly, is the middle number of the data set, and we find this most directly by canceling out from the outside to the in of the data set. So we'll start with 1 and 81, 25 and 60, 35 and 40, 37 and 39, and what we find is that this median of our data set is this middle number here is 38. It's easy to identify that as the median because there are 4 numbers on either side of it. If your data set has an odd number of data points, as this one does with 9, your median will be a part of the data set. If your data set has an even number of data points, your median will not be on the data set. So it is possible to have your median on and off the data set. Please note for a possible test question. The harder ones to find is the first and third quartiles. Often kids forget that you do not take into account the median when finding the first and third quartiles. So today, when we find the first and third quartiles on this problem, we will not use 38. We will start to the left and to the right of the 38. So therefore, if we start working outside in there, we will go with 1 and 37 and 25 and 35. And what we end up finding is that our first quartile falls in between the 25 and the 35. When this happens, we must average them. So we're going to take 25 plus 35 and divide that whole thing by 2. When we do that, 25 plus 35 is 60, divided by 2 is 30. To find our third quartile, we are going to, again, do the same process. So, to find our third quartile, we're going to do the same thing. We're going to start with our median, go to the one to the right of it, which is 39, and our 81, work from the outside in. And what we come to find is that our third quartile falls right here between 40 and 60. So again, to find that, we're going to average them out. 40 plus our 60 gives us 100. Divide that by 2, and we get 50. Now, you should be able to tell that it's a reasonable answer if you did this correctly because the number you get should fall between the two numbers you added together. If you get something different, you screwed something up. Now that we have our 5-number summary, we can easily identify our box and whisker plot. More times than not, we will have a number line under that so that we can see how the box and whisker plot looks, especially later on in this chapter when we talk about skewness. So it's going to be important to have that number line, but for right now we're just going to do a basic one so you understand where these points fall on this box and whisker plot. The minimum is going to be the left whisker, so the far left point is going to be your minimum. The first quartile is the left side of the box. The median is the line that goes through the box. A lot of people say it goes through the middle of the box, but it might not necessarily go exactly through the middle. As you can see with this one, it does not fall exactly in the middle of this box. Our third quartile is the right side of this box. So that's our 50. And then our max is our far right whisker, so as far out as it goes. And what you can tell by this box and whisker plot, even though we don't have a number line on there, is that this thing is shifted to the left a little bit. Our right whisker, our maximum, is a lot further out than our left whisker, and that's because a majority of our points are down in the 30s, which is far closer to 1 than it is to 81. So this box is shifted a little bit, and our whiskers will have different lengths, just like the line in the middle of the box will be in different places depending on what our data set looks like. So that's basic box and whisker plot. Next, we're going to get into checking answers from your homework or conceptual practice last evening. I've got them up here. If you wish to take longer time on them, you may pause. please note one thing on problem number 8 from your reading, that x bar, that's this x with a bar over it, known as x bar in the statistics world, is the mathematical notation for mean. There's your answers to 10 and 12, just one possible option. There are many different options for creating data sets, so do not worry if your answer is not the same as mine or even your neighbor's. So what we're going to do today is we're going to look at 2.1 day 2, which does discuss outliers and more practice with making up data sets. We're going to do 2 outlier problems and a couple of making up data set problems. So to start with outliers, we're going to look at what the definition of outliers is. An outlier is a number that is too far from the box. Now, too far is kind of a vague term, but we're going to make it a mathematical term. And what we're going to identify that as is too far from the box is anything further away than 1.5 times the IQR, which we will get into in the next slide. The box we are identifying is the box from the box and whisker plot. So that's where that middle half of your data set falls. Anywhere outside from too far or 1.5 away from that box will be considered an outlier, and we will look at that in detail in the next slide. So if we go back to our Bellwork problem, here's our box and whisker plot identified with a number line below it, identifying its shift left or right and how long the whiskers are, and the median not exactly in the middle of the box, closer to the first quartile than the third quartile. Our first step to finding our outlier is to take our IQR. An IQR, known as the interquartile range, is our third quartile, 50, and we are going to subtract from it our first quartile, which is 30. So taking our third quartile minus our first quartile gets us our interquartile range. Much like our range of our data set is our max minus our min, our IQR is simply our third quartile minus our first quartile. So we get 50 minus 30, which is 20. That's our IQR. As I said, a statistical too far from the box is essentially 1.5 times the IQR. So once we find our IQR, we're going to take that and we're going to multiply it by that 1.5. That is a standard constant. We will use 1.5 every time we try to find outliers. So that isn't something I've pulled from this problem specifically. That is a number that you will always use when finding outliers. And when we do that and we multiply our 1.5 times our IQR, we end up with 30, which happens to be our first quartile. Please do not assume that that is always the case. That is just mere consequence for this problem. Once we get that 1.5 times the IQR, we're going to find our cutoffs. And what our cutoffs are is we are going to take that number, that 30 that we just found, and we're going to add it to our third quartile and subtract it from our first quartile. And the key here when we're finding our cutoffs is to put those quartiles first. Don't put that number we found first or you're going to get an incorrect answer on the cutoff below. So if we start with the cutoff above, we're going to start with our third quartile, which is our 50. And we are going to add that number we found to it. So add our 30 to it, and our upper cutoff, or our cutoff above, is 80. Same thing, we're going to start with our first quartile below, which is 30. We're going to subtract it from it. So we're going further away from the box by adding to the right side of the box, subtracting from the left side of the box. When we do that, 30 minus 30 happens to be 0. So there's our cutoffs, and what those cutoffs mean is that any number in our data set that is larger than 80 or smaller than 0 is considered an outlier. So what we are going to do then is we are going to go up to our data set and see if we have any numbers smaller than 0, which we do not, and any number larger than 80, which we do. Our maximum of 81 is larger than 80, so it is considered an outlier. So do we have any outliers? The answer is obviously yes, there are outliers, and 80 is our outlier. If we were to dig in a little bit more into statistics, what we would find is that we would remove that outlier from our data set before we did any analysis on the data set. So, I'm going to try one on our own here. I would like you to try one on your own here. Pause it at this moment and go through the first 3 steps, and then when you record again, or when you hit play again, we will go through this. So please at this moment hit pause, and then when you hit play again in a moment, you will have the answers for the first half up on your screen. All right, so what you see here now is the answers to A through C. Our 5-number summary has a minimum at 3, a maximum at 18. As you can see, I crossed off the numbers in the black to the middle to find that my median is 8. And then in blue, I found my first and third quartile by crossing out numbers to the left and to the right of the median. Please remember, we don't use the median to find the first and third quartile. To get my 6.5 and my 11.5, as then the first quartile falls between 6 and 7. The third quartile falls between 11 and 12. Once I have my quartiles, I take my quartile 3, subtract my quartile 1 from it to get my 5, times by 1.5 gives me my 7.5. To find my cutoffs above, I add 7.5 to my third quartile to get 19, and I subtract 7.5 from my first quartile to get -1. So therefore, the question is, are there any outliers? And in this question, there are no numbers bigger than 19. There are no numbers smaller than -1. So no outliers. Next thing we're going to go through is making up data sets, and we'll take just a couple minutes going through 3 data sets based on different statistical things, and then we will be done and you will have your conceptual practice for in class on Friday. So if you look at problem 1 for making up a data set, we need to create a data set that has 3 numbers in it where the range is 12, so that's the difference between the maximum and the minimum is 12, and it gives us that that maximum is 20. So the one number I know already from my data set is that this biggest number furthest to the right is going to be 20. Since my range is 12, I can take my maximum, subtract my range from it, and that will get me what my minimum is. 8. 20 minus 12 is 8. Now, those are the only 2 stipulations here, is that the range is 12, which we already have. 20 minus 8 is 12, and the maximum is 20, which is our biggest number. So the only thing we need to worry about for this middle number is that it's some number between 8 and 20. The 8 needs to be our smallest number for this to work. The 20 needs to be our biggest number. So I can make this any number I want between the 2. I'm going to make it 12. That's what I'm saying, where we could have multiple answers that are completely different, but all the same. You could put any number you wanted to between 8 and 20, and it would still be a correct answer. So that's creating a data set, kind of a basic one to get us started. We look at number 2. Number 2 says create a data set of 5 numbers where the mean is 15, the median is 14, and the mode is 20. I'm going to start with the easiest one in my opinion and work to the most difficult one to deal with when creating a data set for kids. So the first one I'm going to work with is that the median is 14. So if we look at that median being 14, that's the middle number, and since this data set has an odd number of data points, it's actually going to fall on the data set. As I'm done with it, I'm going to cross this thing out saying, yep, I got that taken care of. The mode is 20. If you remember correctly, the mode is the number that occurs the most, and since there's only 2 numbers on the right side of 14, these last 2 numbers need to be 20. So I'm going to make them both 20. In order for 20 to continue to be the mode, the 2 numbers below 14 have to be different from each other. And now where this gets tricky is dealing with the mean. And here's how we find the mean and what the mean needs to be. The mean, if you remember correctly, is all of the numbers added up divided by how many there are. So the sum of all the numbers divided by the number of data points gives us our mean. So as this looks over here kind of generally is we take the sum divided by how many there are, I'm going to label that as n, gives us our mean, which if you remember earlier I said is identified as x bar. Well, in most cases we know the sum, we can add them up, we know how many data points there are, we can divide them to find the mean. Here we don't know the sum, but what we do know is we know how many data points there are. In this case, there are 5. And we know that our mean needs to be 15. So we're going to go the sum over 5 equals 15. So what we need to do then is we need to get the sum by itself. And since we're dividing both sides by 5, the opposite of divide is to multiply. Remember, whatever you do to one side of any equation, you must do to the other to keep it balanced. Our 5's will cancel out here, and we will get that our sum is equivalent to 15 times 5, which is 75. So if all of them need to add up to give 75, I'm just going to start subtracting. I'm going to start with my 75. I'm going to subtract 20, 20, and 14. The three numbers that I know are already on my data set. And when I do that, I get 75 minus 20 is 55. 55 minus 20 is 35. 35 minus 14 is 21. So my last two numbers need to add up to give 21 in order for this thing to completely add up to give 75. They both have to be different numbers, and they both have to be less than 14. And so the answer I'm going to go with is I'm going to go with 10. Oops, 10 needs to be the first one. Just thinking ahead of myself. 10 and 11. I could have other options that had to give 21. I could go with 9 and 12 as well, would still give me 21 and still be different. But there's my data set. I see that my median is 14. 20 is the number that occurs the most. And if I add all 5 of those up, 20 plus 20 is 40. 40 plus 10 is 50. 50 plus 11 is 61. 61 plus 14 is 75. And therefore, if I take 75 divided by 5, I do get my mean of 15. So therefore, I also know now that my mode is 20. I got that taken care of. And my mean being 15 is taken care of. There's my data set. Last one of the lesson. We're going to make up a data set that's got 6 distinct numbers. That's the key, is that it's distinct numbers. Every number is different. So we're going to create 6 numbers. So I'm going to go 1, 2, 3, 4, 5, and 6 numbers. It says that it has to create that box plot below. Well, I know my 5 number summary is 3 is my min, 6 is my first quartile, 25 is my median, 31 is my third quartile, and 35 is my max. Again, like when we created the box and whisker plot at the beginning, I'm going to start with the 2 easiest ones. And that is our min we know is 3. Our max we know is 35. Since this data set has an even number of points, our median is going to fall right here, and that's our 25. I'm going to tell you right now the easiest way to get that to be 25 is to, since they have to be distinct, they can't both be 25. So I'm going to go one below 25, gives me 24, and one above 25 is 26. That way I always know they average to 25. So I always do that when it falls off the data set. Put one below it and one above it. Now, since our median falls off the data set, we are going to use our 3 and our 24 as crossing off to find our first quartile, and our first quartile does fall right here on our data set, which makes this easy. First quartile is 6. Same thing happens for our third quartile. If we were to cross off the 26 and the 35, our third quartile would fall right here in this middle slot, which is 31, and there we have it. Our 6 distinct numbers that give us a box and whisker plotter, a 5 number summary of 3, 6, 25, 31, and 35. I hope this helps with you in better understanding for what outliers are. Please remember that outliers are any number that are too far away from the box as identified by 1.5 times the IQR. And please remember to take your time specifically with finding the mean and making sure that you find the sum is the key to figuring out what data set creates a mean of a particular number. Your conceptual practice for Friday, which you will receive during class, is going to be a worksheet that's some extra practice on making up data sets and then also finding outliers. We will go through that and everything else in our next class together on Monday before we start standard deviation. Have a good weekend.